looking up there. Okay, so, but I got both screens recorded. So let's do something like 42. And then we'll graph it. I'll just graph it over a single interval. So on page 166, 42. We get y equals 3 cosine 4x plus pi. Now remember that in order to be able to use that, I think the first method that they say, what should we do with this thing? Should factor that 4 out, right? So it's out in front here. And then we would have x plus pi over 4. Remember, the two methods that I'm talking about is if you, remember we stumbled around a little bit. Well, on page 160, it's showing you graphing y is equal to a cosine bx, b times the quantity x minus d. There's a method 1 and there's a method 2. And they show you one where that value right there is inside the bracket. And in order to get your period right, you got to get it out, right? And the phase shift correct. So the first thing we want to do is we want to talk about the amplitude of this. And the amplitude is going to be for this one what? Yeah. And what you should do is put absolute value of whatever this is with the sign out here, because then if it's a negative, you know that it's an inverted, right? Remember that? It's an absolute value, and then put what, if there's a negative sign, put that negative in there, then that's your reference to go back and say it's the cosine, but it's inverted, right? Rotated around the x-axis. This one isn't rotated, it's a regular cosine. Then the next thing we talk about is the period. And remember, the period for the cosine is 2 pi long. The period for something like this is 2 pi over b, and this value is b. So this is going to be 2 pi over 4. So our period is pi over 2. So that's the length of the period that the cosine is going to be run across. Then we talked about vertical shift, right? And for this one, the vertical shift would be something added or subtracted on the outside here. And the vertical shift here is 0, correct? And then horizontal. It's a horizontal shift or a phase shift, depending on whichever way you call it. It can be horizontal. If you've taken college algebra, it was referred to horizontal. For trig, it's called a phase shift. Those both mean the same thing. So this is the phase shift. Now, remember that if you look at that form, what I have this thing in is this form. Y is equal to C plus A cosine B x minus D. Notice that this, I've got it right here, right? I got the amplitude was this value. The period is this B, and you have to have that B on the outside. right? You can't have it inside here like this, because that makes my period. That way we can get this phase shift right. The phase shift isn't pi, it's pi over 4, because that's d. Now, notice it's a minus d, so in order to be a minus d, this has to be minus a minus pi over 4, right? So d has got to be a minus pi over 4, which means it's shifting it to the left. Just whenever you see this as a plus, it shifts it left. Whenever that's a minus, it shifts it right. However you want to look at it. So pi over 4 left. Now let's see. Now, what the next thing that I told you to cross-check all of these things, what you want to do is you want to do something called the interval. In the interval for cosine, the interval always for just a normal cosine is 0 less than or equal to whatever's in here and 2 pi, right? But now what you do is you can either put this thing in the middle or you can put this. It won't make any difference. I'm going to put it this way. 4x plus pi over 4.
Do you need the 4 in there since we kind of already factored it out?
You can, I'll show you. No matter which way you do it, it's going to come out to be the same. Let me finish this one. The first thing we'll do is we'll divide by 4. Right? We divide this by 4, this by 4, and this by 4. So then we have 0 is less than or equal to x plus pi over 4, which is less than or equal to pi over 2. Correct? And now what we have to do is we've got to subtract pi over 4. So we'll subtract pi over 4 here. So we get x by itself. That's what our goal is. So the result of doing that is a minus pi over 4 here. That's where our interval begins, less than x, which is less than or equal to, and then if I get pi over 2 minus pi over 4, that's pi over 4, right? So this is the interval over which I'll graph that. Now, how long is that interval? Pi over 2 long, right? So I can see if this is the interval, I've done this right. And that means that I correctly adjusted this 4 out, because if I wouldn't, I would have said, well, I'd have done a phase shift. Now let's just say the phase shift would have been wrong. Notice that this thing shifts phase-wise where? Rather than starting at 0, it starts at negative pi over 4. So that's shifting it to the left. It's a phase shift to the left. So that's what it verifies this. Now, James, in order to show you that no matter which way we do this, it's going to mount. We're going to have that same thing. I'll do it 0 less than or equal to, which is less than or equal to 2 pi, and then I'll put it in this way: 4x plus pi. Okay. Now, when it's this way, I have to subtract pi first. See, when it's written this way, I divide by 4 first. Correct? So I have to, this one, I have to subtract pi first. I could divide by 4, but then I'd get pi over 4 here. So I subtract pi, and that gives me a minus pi less than or equal to 4x, which is less than or equal to pi. Now I have to divide by 4. And my answer is a minus pi over 4 less than or equal to x, which is less than or equal to pi over 4. Now, does this answer where you was kind of questioning, James?
Sure.
Don't make any difference which way you do it. When you're doing interval, it's going to give you the same interval. And you will be able to see that's the phase shift left, that the length of this interval is pi over 2 long, right? Because it's the ending minus the beginning.
Could you do me a favor and show on the first way you were doing it, the second one from the bottom, pi over 2 minus, on the right of that, pi over 2 minus pi over 4. How does that right below your thing?
You mean this one here and to here?
Right.
See, if I take 2 out, 2 into 4 is 2, so it's pi over 2. So I'm taking 2/4 and reducing 2/4 to 1/2.
Right. And then the next step.
Then I subtracted pi over 4. So this is actually 2 pi over 4, right? Minus pi over 4 is pi over 4.
Some of those fractions.
The fraction things that get, yeah.
Wait a second. All right, I'm with you.
Yeah. Now, any other questions on it? Do you see? Now, if you do it in method A, or that first method on that page, this is what you've got to do. You've got to remember to not, you messed up on this phase shift if you don't factor that 4 out and write it this way, right? When you're trying to pick phase shift right straight off of here and not do an interval and see what the phase shift is. So if you recall, I said Monday that the best thing to do is use a combination of method 1 and method 2. Do your thing by method 1, then do the interval and make sure the interval works, verifies what you're doing with method 1. Now I wanted to try and graph this over one interval. So I'm going to try to graph it right over the top of this mess. So what I'm going to do is I'm going to do green. And notice we're going to have to go minus pi over 4 to pi over 4. So I'm going to come back here and I'm going to say this is a negative pi over 4. And then this is positive pi over 4. Because that's the interval that I said that I should graph it over, right? Now, my amplitude is 3, so I would go, I guess I'm going to go 1, 2, 3, 1, 2, 3. Now then, I break my interval into 4 parts. Here's the beginning. Here's halfway, that's 0. Here's half of that, which is going to be 1/4 of the way. So this is going to be what, pi over 8, negative pi over 8. This will be plus pi over 8, because that'll be half of the pi over 4, right? So my 5 positions, beginning, 1/4 of the way, half the way, 3/4 of the way, and the end of the way. And it's the cosine function. So the cosine function, and it's not inverted because there's no negative. At the beginning of my interval, where is it going to be? Is it going to be 0, max, minimum? It's going to be at its maximum at the beginning. So my cosine function is going to be max, and remember the max is 3. It's at the top of my amplitude. Now 1/4 of the way into my interval, what am I going to be at? 0, right? It'll be right here. I'm gonna do this in red, just maybe a beginning, 1/4 of the way. Now, half of the way, where am I going to be? Minimum, right? 3/4 I'm at 0, and at the end of, I'm up here. So this is the graph of the cosine. Okay. Remember, there's two. It's always the interval And so you see this interval is going to be what you graph it over. That's why that method 2, where you find that interval, it's better because then it'll show you where you're going to graph the normal function. And it's always going to be, for cosine, it's going to be what? Beginning point is at its maximum, fourth of the way in it's 0, half it's minimum, 3/4 it's 0, end max, right? For the sine function, it's going to be what? Beginning is 0, fourth is max, right? Half is 0, 3/4 is minimum, and then at the end it's 0. So what you, and notice that I didn't say 1. 0 I did use, but you're going to have to remember when this translates up or down, that 0 is going to be on that translated axis. But I used maximum because the maximum is 3, it isn't 1. Okay? Now, I'm gonna skip over and I'm gonna do 53 through 56. I've decided to do this whole chapter, so it's going to take me a little longer. I'm going to have to not do all as many problems as I normally may, because we got material to cover. What you should do is you should practice. Obviously, you should practice these at home, right? And then if you have questions, then come back and ask me. Okay, I'm going to do 54, because notice what it's going to be. It's going to do a vertical shift, right? It's going to do a phase shift horizontal. It's going to do, I should do 56 because that's going to do a vertical. It's going to do a horizontal. It's going to change the period and do a bunch of stuff, right? So I'll do 56. 56. And this is y equals a negative 5/2 plus, I guess it doesn't, none of these do everything. I wish that it had an amplitude change, but it's not. X minus pi over 6. Now, recall that the form we're looking it to be like y is equal to c plus a cosine b x minus d. So with that information, then my amplitude is going to be what? Absolute value of 1. It's right there. Now, notice it's not an inverted cosine, so I don't have to worry about that. Then my period. My period is going to be, well, just doing it in red, 2 pi over b. So that's going to be 2 pi, and what am I going to put b as? 3. Now that don't reduce, so that's my period. My vertical shift is going to be what? Negative 5 over 2. Now, just for the sake of kind of being able to figure it out, it's a negative 2 1/2, right? So that means my horizontal axis, rather than being the x-axis, is going to be where? Down at negative 2 1/2, right? That's where that's going to be. So when I talk about 0, in my cosine function, I'm going to have to be at that point, right? Now, my phase shift Now the way I've done this is notice that this pi over 6 is going to be the phase shift, but which way is it? Right or left? It's right. That's correct. Whenever you see it this way, and this is negative, it's right. If that's a positive, it's left. Because notice that if I put it in this form, then it would have to be a negative plus pi over 6, and that means it goes right. Now then, my intervals, the next thing I want to do. In my interval, I'll set up my normal cosine interval, 0 to 2 pi, and then I'm going to put this value in the middle, 3x minus pi over 6, and then I'm going to try to get x by itself, right? So the first thing I have to do is divide by 3. So I can divide this by 3, this by 3, 3 here. So I'm going to go 0 less than or equal to x minus pi over 6, which is less than or equal to 2 pi over 3. Now I have to do what? Subtract add the pi over 6. And this is going to be pi over 6 less than or equal to x. Now I get x by itself, which is what I want. But now I have to have a common denominator. So this is going to have to be 4 pi over 6 plus pi over 6 is 5 pi over 6, right? Now, here's the interval that I'm going to graph the cosine function, right? It's a cosine. And how long is that interval? Well, I subtract pi over 6 from 5 pi over 6, 4 pi over 6, and that's 2 pi over 3, and that's what I said my period had to be. So I verified that this period matches here. Now then, what I want to do is I want to lay this out. And it's going to be pi over 6 to 5 pi over 6. So I'm going to have to have 5 divisions. 1, 2, 3, 4, 5. So if I call this pi over 6, I can call this one 5 pi over 6. Is that right? Yeah, 5 pi over 6. Now, halfway between is going to be right there. Notice we divided into 4 equal parts, right? So this one is, well, halfway between has got to be 2 more than this, so that's going to be 3 pi over 6. And this is 2 pi over 6, which reduces to pi over 3. And then this is 2 pi over 3, right? Now what I want to do is this has got to be vertically down 2.5. So I'm going to come 1, 2.5, and I'm going to run. That's going to be my new 0, right? And then my amplitude is 1, and it's a positive 1, so it's not an inversion. And this is the cosine function, right? Cosine. So I start at the beginning of my interval, which is right here. I start 1 up from my baseline, right? So where am I going to be at? Right there, correct? I'm going to be 1.5 down. Because the cosine is at its maximum, right? Then a fourth of the way in, it's at its what? 0, so that'll be this translated x down, and then halfway it's going to be its minimum, so it's going to have to be down here. And then it's going to be at its 0 translated, and then back at its maximum. So then this thing should look like, that's over its one interval. You could do it, if you wanted to, you could do it on an interval back here if you wished, or an interval out here. That would be it, one interval, but it's a convenient interval because it's one that translates, everything translates to. Does that make? Sometimes when you're doing it, it's kind of hard to keep it straight. Now what I'm going to do, I'm going to tell you again, I'm not going to ask for a graph. I'm going to ask you to do all this stuff: amplitude, period, vertical shift, phase shift, and interval. Give that stuff to me, because I wouldn't want to grade this one if I were looking at it. And I know that some of you maybe are better than me, and some of you are a lot worse than me. And I don't want to look at worse stuff than this. Looking at mine's bad enough. Isn't that right, Lucas? Now, what is it that I told you we could do if we wanted to check it? We can go into our calculator, and we can go up here into y equals, and then we can put this function in, right? Does it really? Okay. Now what you wanted, where am I at with there? Over here. Now, which negative sign are you going to put in? This one. It's because it's the first negative in that. See, it's a minus 5/2. So I'm going to put a minus 5 divided by 2. And then it's saying what? Plus. Wow. Is that blurry, or is that just my eyes? Probably my eyes. Cosine, and this is going to be 3. Now remember, when you put it in like this, it's going to give you a bracket, but this is 3 bracket cosine, so you're going to have to put a bracket inside that bracket, right? To have it look like this. See, because that, do you understand what I'm saying? It's going to give you a cosine bracket. You can't put that 3 before that bracket. You have to put it after. Then you got to put another bracket. Double brackets. Are you good with? Yeah. Okay. Then do x. James, you just don't cooperate with me and shake your head yes or no. You understand? I'm looking. Okay. you look at it and you don't. I'm kind of looking at everybody, and you're kind of like, I'm just complaining. 6, and then I got to go bracket and bracket, right? Now, did I put it in? The last bracket corresponds to the one before the 3, and then the next to the last bracket corresponds to the one just after the 3. Okay. Now, what I want to do is probably I want to see it in this format, this trig format, right? So, and that, remember, that is going to start me out on minus pi over 2 and go to pi over 2. So now I got to kind of translate. See, I'm down 2.5. That horizontal line would be right in there. That looks right, don't it? And then I'm going to start out at my maximum, and that is pi over 6 in, right there. Now, if you want to try and figure this out, there's another way that you could do it. I'll show you another way. You could do this trace, and then you could go where I'm at there, I could move this across and try to see there at y, I'm at a minus 1.5. That's where I should be, right? I should be 1.5 down. One up from 2.5 down, right? Because this 5/2, which is a negative 2.5, translated this horizontal axis down to 2.5. And then cosine says I'm at my maximum. So my maximum being my amplitude is 1 up from this translated graph down. That makes sense? And so this thing at that maximum point is telling me I'm at a negative 1.5. And then this, see, it's given me a decimal rather than, it's given me a decimal here. And that decimal, I bet you, is pi over 6, right? Now, another way you could do this thing, if you wanted, and then you can see that here's 1, there is where I would be at the end of my cosine cycle, right? So I can check and run my cursor over through the 1 cycle. And notice it's back up there at negative 1.5 again. And this should be that 5 pi over 6. Now, if I want to verify the 5 pi over 6 and pi over 6, what I can do is I can go second, and you see right up these blue things. This says table setup. And what I'm going to do is I'm going to go down here, and I'm going to say on the independent variable, I'm going to ask. That is, I'm going to put a value in and make it spit the answer out, the y value back to me. So now I'm going to go second, and I'm going to show a table. This is like a T table, right? And now what I'm going to do is I'm going to put in pi over 6, second pi divided by 6. What value should I get out? Negative 1.5, shouldn't I? Because that's the beginning of my interval. Let's see right here. No, I didn't. Yeah, plus pi over 6. My interval is from pi over 6 to 5 pi over 6. So I should get my negative 1.5, correct? So I'm going to go in here, and that's what I got. Now, if I wanted to go all of those different things at pi over 3, so I could put second pi divided by 3, which is where? How far into my interval am I? 1/4. And what should I get for an answer there? Are you interested in taking trig? We're just doing cosine functions with translations of axes. Okay. Well, you're in the wrong class. Yeah, I could work on them if you want. We maybe all could work on it. I know it. So what is the value that I think I should get at pi over 3?
Sorry, it's not 0. It's what 0 is.
Okay, and what was that? That's a vertical translation. So where am I at with my vertical translation? Negative 2.5, right? So I'll go down here, and it says go to, and I made a mistake. So I'm going to come down here and go to. Oh, see, I put a double divide, didn't I? Delete that thing out. So I put divide in there twice. Notice, see what I did when it says an error? I don't quit. I do what? Go to, and then it takes me right to where it detected the error, or close. Now see, I'm just verifying that what I did was right, correct? And then I can just go on through. What would be the next checkpoint that you'd want to check? That 3 pi over 6, or is that say 3 pi over 6? That's pi over 2, isn't it? Isn't that right? I can't see from here.
It's the green color.
I have, like, good thing I got this stuff to look at. I'm going to have to go to the eye doctor. I'm having a heck of a time seeing. See, I got the wrong thing. Second pi, right there's pi, divided by 2. Now it should be what? Should be at that 2.5 with down a -1 from that, -2.5, so it should be -3.5. Right? So you can use your calculator then to verify that you're done it right. Is that making sense? And what I would do is I wouldn't try to go in between there. I'd just go to my 5 points. All right, I'm done with this section. So we're going to do that. You say I'm tired of it? Okay, the next section is the tangent and cotangent curves. And what I'm going to try and do, I'm going to try to give you a justification for these. And the sine and cosine curves, that's what I'm going to do. Because this is, I'm going to try to tell you why I'm going to do this. Tangent of some value x is equal to the sine of the value over the cosine value, right? Now, that says I'll get an idea of what the graph of sine and cosine should be if I tangent should be if I graph sine and cosine. Will you buy that?
Sure, I can buy all kinds of stuff.
So if I graph sine and cosine, then I might be able to see what this thing looks like, right? And I'm going to go 0 to 2 pi. So I want to, I wonder if that's going to be wide enough apart. Can I go? I can't go 2. I can't 1, 2, 3. I'm going to have to go make my things 1/4, 1/2, 3/4. So this is 2 pi. And then halfway is going to be what? Pi. And this is 3 pi over 2. And this is pi over 2, correct? Then if I go back here, this is going to be a minus pi over 2, minus pi, minus 3 pi over 2, and a minus 2 pi. And if I go 1 and minus 1. Now, let's do the sine curve in blue. The sine curve at the beginning of the interval, in the interval 0 to 2 pi, right? The beginning it's at what? 0. 1/4 of the way it's at maximum. Half the way 0. 3/4 minimum, and like that. So it goes now that says for it to go on, this thing here has got to be picked up and put right back here, right? So it starts 0 and goes minimum, 0, maximum, 0. Right. You good with that? That's the sine over 2 intervals. Now let's do the cosine over the same 2 intervals. And let's start with the one that we're used to. At the beginning, it's at its what? Max. 1/4 the way then it's down here at minimum right there. 0, max. So this cosine and then when you come back here, it goes to 0, minimum, 0, max. Roughly speaking, right? Now, let's do tangent. Now, notice that where is cosine? Cosine is in the denominator. And notice cosine is this green. Cosine is green. And sine is blue. Now, cosine is 0 right there. That means I'm going to divide some number by 0. And by the way, when I'm here, the sign is -1, but I'm dividing by 0. Is that a defined number? It's undefined. So what happens, it's an undefined number, so what happens for the graph of this is that the place where cosine is 0, you're going to get something called a vertical asymptote, where the tangent curve can't cross that. Now, where is to the right of 0, 0, where is cosine 0? Pi over 2. So it's undefined there, so I have this. It's not defined here. Now notice where else isn't it defined? Right there. Where else is it not defined? How far apart are those undefined points? Pi. Every one of them are pi apart. Now let's just think about when I'm here, right here, the sign, which is blue, is going to be what? Right there. 0, isn't it? And the cosine right there is what? 1. So this is 0 over 1. 0 over 1. So what is the tangent right there? 0. Right here, the sign is 0 once again, the blue line. The cosine is -1. So I got 0 over -1. What is that number? 0. So all of these right there is 0, right? Right here it's 0. If we go clear back there, and here it's 0. Correct? Now, let's start here at the origin. When I go to the right, I'm starting out at tangent is 0. And then what happens is the numerator becomes a positive number, right? Sine, the blue line is positive number. The denominator is a positive number. But now see what happens? As I get up here, the numerator gets bigger and bigger and bigger. The denominator gets smaller and smaller and smaller until it finally goes to 0. What happens to this? As you're taking a number that's going towards 1, dividing it by a number that goes towards 0. What is the quotient going to be? Okay, let's just leave the sign to be 1, positive 1. Let's take the denominator and divide it by smaller and smaller numbers. It gets bigger and bigger, don't it? You know, you divide it by, first of all, you divide it by 1/2 inverted is 2. 1/4 inverted is 4. 1, you know, right? It gets smaller and smaller. And you can go 1 over 1,000 when it gets really close here. the value of that cosine is going to go 1,000th, 1/10,000th, 1,000,000th. It's just going to get infinitely small, right? Because it's going to 0. And so what's going to happen, this tangent curve is just going to get big. So on this side, that tangent curve gets bigger and bigger until finally the denominator gets to here and it disappears, right? Now on this side over here, notice what's happening. The cosine is denominator is a positive number, and the numerator is negative. So you got a positive divided by a negative. What's the number going to result to be? Negative number, right? And what's your cosine doing? Once again, it's going towards 0, right? So what is this one doing on this side? Going towards what kind of thing? Negative infinity. So this goes down like that. That's what the tangent curve looks like over a period of pi. Now notice what happens. Here we're at 0. When we go towards this vertical asymptote, notice we have 2 negatives, which are positive, right? And notice the denominator is going to 0. So what's happening to the line as it goes here? It's going up like that, right? And here we have a numerator that's positive, a denominator is negative, so it's negative on this side. So it does that. How long is it taking that tangent curve to repeat itself? Pi. Every pi it's going to do it, right? Now, the interval that we're going to do it over is from minus pi over 2 to pi over 2, because that's where it's continuous. Do you see if we went from 0 to pi, we'd have this part and this part, right? It's not as handy to do. It's handier to say from minus pi over 2 to pi over 2. It's a pi. Now, from minus pi over 2, we're pi over 2 distance here, we're pi over 2 distance here, that's pi. Sum of pi over 2 and pi over 2 is pi. But it's just a convenient thing that we say it's from, the interval is from minus pi over 2 to pi. And then it looks like this. Now we're still going to divide this into 4 parts. At the beginning, it's going to be what? A vertical asymptote. 1/4 of the way, it's going to be below, right? Halfway, it's going to be 0. 3/4 of the way, it's going to be above 0. And at the end, it's going to be vertical asymptote. That's the way we're going to describe tangent. Now, I want you to do this. Graph the sine and cosine curve, and then invert this to do cotangent and see what happens. And see where it's continuous. This is what you're going to find. It's going to be from 0 to pi is going to be the interval you want to choose, but the cotangent is going to go a reverse flip. Graph the thing out, see that you can understand it. And then what I'm going to do when we come back is I'm going to start doing these tangent, cotangent things. All right? Okay.